So our local national weather is influenced by air masses. Air masses are large regions of air with uniform characteristics at any level. In other words, it's going to have the same characteristics from which it comes from or from its origin. For example, if you have an air mass coming from northern and central Canada, the air mass is going to be very cold and very dry. If you have an air mass that's coming off the ocean, say from the north, it's going to be cool and moist. If you have an air mass coming from the south, from the Caribbean, say around Florida, the Gulf of Mexico, it's going to be warm and humid. And if you have an air mass that's coming off, say, from areas like Mexico, Texas, New Mexico, Arizona, it's going to be warm and dry. Now, we have names for these type of air mass. Okay? We have what we call maritime polar. We have continental Arctic, continental polar, maritime tropical, and continental tropical. Okay, now the main thing here, you have to be able to recognize the terms and what they mean. So anytime you see the term maritime, maritime refers to water. Water is moist or it can be humid. So if the air mass is coming over water, it's going to have moisture with it, and there's going to be some humidity involved. When something's continental, think of the word continent. So continent is land. So if the air mass is coming from land, the air is going to be dry. When something's tropical, we know it's hot. If you've been into the tropics or the Caribbean, okay, it's hot. Polar. Polar is cold. Think about the poles. Polar bear. A polar bear's habitat is where it's cold. And in the Arctic, the Arctic is near the North Pole, and we know the North Pole is very cold. So these are the terms. Once you put them together, then you can understand the characteristics of these air masses. Now, when different air masses come together, they form fronts. So the boundary between them, okay, the boundary between air masses form a front. And we have four types. We have our cold front, we have our warm front, we have our stationary front, and we have our occluded front. Now, essentially, a cold front, and if you notice, they have designated symbols. So you find this, okay, you find this portion right here on your reference tables. Okay, now, very important, there's a couple of things that we really need to understand. Essentially, a front is a leading edge of an air mass. So if you have a cold front, that means it's a leading edge of cold air. Everything behind it is cold. And it's advancing towards an area where you have warmer air or warmer temperature. So think of the symbols here as almost like an arrow. It's telling you the direction that the air mass is moving. And typically on a weather map is pointing towards the east. Okay? So just think about it in an army. You have a cold army advancing towards a warm army. And eventually these temperatures, as the cold front passes, these temperatures will lower. So from 55 it could go down to 45 degrees. And from 62 it could lower down to 52 degrees. Now, warm front is the opposite, where you have warm air advancing towards cold air. Alright, so we have these symbols where we have our semicircles, our red semicircle. And again, it's pointing towards the direction of movement. Okay, again, they're almost like arrows. So they're pointing in the direction of movement. So eventually, the warm air is going to cause these temperatures to rise from 28 to maybe, say, 38. And from 31, maybe, say, maybe 43 degrees over time. Stationary front means the two air masses are locked into place and they can't go anywhere. So it's stationary. When something's not moving, it's stationary. And an occluded front is almost like a sandwich. Basically, you have cold air, or you have warm air between two cold air masses, and it's forcing that warm air to rise. Okay, so these are the four main types of fronts.